Hello everyone, myself Dr. Aditi Chatterjee. Today I will discuss on the topic Routh Hurwitz stability criteria. So in the previous lecture, we have already seen that if we have a open loop transfer function, then finding the roots from the by finding the roots or the location of the poles from the given transfer function, we can comment on the stability of the system. But suppose if the polynomial function in the numerator and denominator have higher order, then we can choose Routh Hurwitz stability criteria to comment on the stability. So basically, in Routh Hurwitz stability criteria, it is a mathematical test used in control system theory to determine the stability of a linear time invariant dynamical system without solving for the roots of the characteristics equation. Means if the polynomial function in the denominator have some higher order, then it becomes a tedious job to find the roots of the equation. In that case, like if we have order like s to the power 5 or s to the power 6, in those cases we can use to form uh, array array table, which is known as Routh array, and which helps us to find the or which helps us to comment on the stability of the system. In Routh Hurwitz criteria involves constructing a specific array, which is known as Routh array, using the coefficients of the characteristics point polynomial. By analyzing the sign of the elements in the first column of this array, you can determine the number of roots in the right half plane, which indicates instability. Means we have seen that if we have a single root in the right half plane, then the system gives a unstable response. So that implies the system will be unstable. So from the Routh array, if we find or if there is any sign change in the first column of the array, that will imply the number of, from there we can find out how many roots of the system will be in the right half plane. It is widely used in control engineering to analyze the stability of feedback control system without solving for the poles of the characteristics equation. Now, the condition for stability is if all the elements in the first column of the Routh array have the same sign, either all positive or all negative, the system is stable. If there are sign changes in the first column, the system is unstable. And the number of sign changes corresponds to the number of roots with positive real part. That is, number of roots that will locate in the right half plane. Now, how we design or how we construct the Routh array. Suppose let us consider a general equation, a general polynomial characteristics equation given by a0 s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2. Likewise, we are having it up to an s to the power 0. Now what we'll do, first we will write the highest power of s, means here we have s to the power n. Likewise, we'll go down s to the power n, s to the power n minus 1, s to the power n minus 2, up to s to the power 0. Once it is done, now we will write the coefficient of s to the power n, which is a0. Now after writing a0, see here we have written a0. Now after writing the a0, we will take the a2. Okay, we'll take a2, the power means the coefficient which we are having for s to the power n minus 2. So a2 we have written here. Then which one we will write? We will skip s to the power n minus 3 and we will write it for s to the power n minus 4. So obviously that will be 8, 4. So likewise, we will continue this till end of the polynomial function. means up to s to the power 0. Then what we will do, we will write the coefficient of s to the power n minus 1, which is here we have a1. Okay, so after a1, which one we will write? We will write a3. Okay, means the coefficient for s to the power n minus 3. So a1, a3, a5, likewise we will continue. Okay, so first we are starting with coefficient of s to the power n, which is a0. Then we will skip one and then we write a2, then a4, then a6, likewise. Then what we had been, we are writing the coefficient of s to the power n minus 1 and then alternate a1, a3, a5, a7, likewise. Now, then b1, b2, b3, c1, c2, all we will calculate from these two rows. And, and how we will do that? For getting b1 will be a1 into a2 minus a3 into a0 by a1, means minus determinant of these four elements. Okay, a1, a2 minus a3, a0 by a1. Now when you will be calculating b2, that will be a1, a4 minus a5, a0 by a1. Okay, now for b3, that will be a1, a6 minus a7, a0 by a1. Likewise, now when you will be calculating c1, that will be b1, a3 minus b2, a1 by b1. For c2, it will be b1, a5 minus b3, a1 by b1. So likewise, you can construct the Routh array. It will be more clear when we will be considering one example. So let us take an example. The characteristics equation is given. Suppose if the open loop transfer function is given, like GS or GSHS is given, then you have to get the characteristics equation. How we get characteristics equation? By 1 plus GS or 1 plus GSHS. So here the characteristics equation itself is given. So the characteristics equation is basically a polynomial which is s to the power 4 plus 3s cube plus 3s to the s square plus 2s plus 1. So the highest order of s is s to the power 4. So first we will write s to the power 4, s cube, s square, s1 and s to the power 0. This first we have to write. Then the coefficient of s to the power 4 is 1. So we are writing here 1. Then which one we will take? We will take these three. These three. Then we have 1. Complete. Now for s cube, we have the coefficient 3. So we will write 3 here. Okay. Then which one we will take? We will take these 2. This is how we are writing the coefficient. So first we have to write coefficient of s to the power 4, which is 1. Then we will take the alternate 3 and 1. And for writing the coefficient of s cube, that is 3, then we have 2. Now for s square, we have to calculate it. How we will get that? 3 into 3 minus 2 into 1 by 3. So that is basically 7 by 3. Now for calculating this element, we have 3 into 1. And when we have nothing, we will simply put 0. 0 into 1 by 3. 3 into 1 minus 0 into 1 by 3. So that is basically coming 1. Now for calculating this element, we have what we have to do? 7 by 3 into 2 minus 1 into 3 by 7 by 3. So that is coming 5 by 7. Now for calculating this element, 5 by 7 into 1 minus 7 by 3 by 7 by 3. So basically, 5 by 7 into 1 minus 0 into 7 by 3 by 5 by 7. So basically that is coming 1. Okay, this is how we construct Routh array. Now see here in the first column, all the elements are positive. There is no sign change in the first column of the Routh array. So we can comment that there will be no root located in the right half S plane. So thus we can say that this type of system will give you a stable response. So this control system, this particular control system is stable. Okay. So this is how we construct Routh array, and we can comment on the stability of the system. Thank you. See you in the next lecture.